Physics is broken. The most successful theory in human history just failed a test it was supposed to ace. For 50 years, the Standard Model predicted everything. It explained the sun, the stars, and the atoms in your body. But deep inside a magnetic ring in Illinois, a subatomic particle is wobbling faster than the laws of the universe allow. It's not an error. It's a message. Something invisible is pushing back. And it proves there is a fifth force of nature waiting to be found. This discovery changes the definition of reality. But to understand why, we have to look at the ghost in the machine. Scientists are calling it the last hope for new physics. And the results are finally in. But be warned, the answer isn't what anyone expected. It's much, much stranger. Everything we thought we knew about the empty vacuum of space. We were wrong. There are monsters hiding in the dark, and we just poked one with a stick. Before we reveal the data, you need to understand the stakes. Because if this wobble is real, the Standard Model is dead. Physics relates to four fundamental forces: gravity, electromagnetism, the strong force, and the weak force. These four pillars hold up the entire universe. And the blueprint for how they work is called the Standard Model. Think of it as the most accurate map ever drawn. It predicted particles decades before we found them. It predicted the Higgs boson. It predicted the top quark. It has never ever been wrong. Until now. Because the Standard Model has a blind spot. It can't explain dark matter. It can't explain gravity at a quantum level. It's incomplete. Physicists have been desperate to find a crack in the armor. A loose thread to pull. Enter the muon. The heavy, unstable cousin of the electron. Muons are fat. They are 200 times heavier than electrons. And they live for only 2 microseconds. But in that short life, they do something incredible. They act like tiny magnets. When you put a muon in a magnetic field, it wobbles. Like a spinning top losing speed. This wobble is called G, and the Standard Model predicts a Ju with agonizing precision. If the muon wobbles even a fraction of a percent faster than predicted, physics breaks. Why? Because particles don't wobble alone. They interact with the virtual soup of the vacuum. Every known force pushes the muon. Gravity, electromagnetism, all of them nudge it slightly. If it wobbles too much, it means something else is pushing it. Something unknown. To measure this wobble, scientists needed a magnet. A big one. The most precise magnet on Earth. It was built at Brookhaven National Lab in New York. But they needed to move it to Fermilab. The problem? You can't twist it. You can't bend it. If the ring flexes by a millimeter, it's ruined. They couldn't drive it on the highway. It was too wide. So they did something insane. They put the 50-foot particle accelerator on a barge and sailed it down the East Coast, around Florida, up the Mississippi River. A 200-mile odyssey for a physics experiment. People lined the shores to watch. It looked like a UFO being transported in secret. When it finally arrived in Illinois, the real work began. They had to cool it to near absolute zero. They inject billions of muons into the ring. The particles race around at nearly the speed of light. As they race, they decay. When they decay, they shoot out electrons. Detectors catch these electrons. By mapping them, we can reconstruct the wobble perfectly. It took years of data collection, blind analysis. No one knew the result until the very end. To prevent bias, the clock frequency was encrypted. A secret envelope held the key. On reveal day, they typed in the code. The graphs aligned, and the room wasted. The experimental value didn't match the theory. The gap was massive. 4-2 sigma. In physics, 5 sigma is a discovery. 4-2 is a screaming alarm. The chance this was a fluke, 1 in 40,000. It was real. The muon is being pushed. The Standard Model is wrong. Headlines exploded. Fifth force found. Physics broken. But there was a catch. Science isn't that simple. Because while Fermilab was celebrating, another group was plotting. A team in Europe used a supercomputer to recalculate the theory. And their answer was different. They claimed the Standard Model wasn't wrong. The math was just harder than we thought. According to their new calculation, the Standard Model predicted the wobble perfectly. There was no gap. Chaos erupted. It was a civil war in physics, the experimentalists versus the theorists. If the supercomputer is right, Fermilab's fifth force is just a mirage. a ghost created by bad math. But if the supercomputer is wrong, we are back to broken physics. Nobody knew which reality was real. For months, the discovery hung by a thread. It felt like the biggest false alarm in history. The media moved on, the hype died down, the champagne was put back on ice. But the Fermilab team didn't stop. They doubled down. They ran the experiment again. August 2023, they released the new data. 4 times as much data as before. The precision was insane. It's like measuring the distance from New York to LA to the width of a human hair. The result? The gap didn't close. It got wider. The wobble is real. This means the discrepancy isn't in the experiment. It's in the theory itself. Something is wrong with how we calculate the universe. The supercomputers missed something. The crisis shifted. It's no longer is the data wrong. It's what are we blind to? The door to new physics didn't just creak open. It was kicked off the hinges. So, if it's a fifth force, what is it? What does it do? Physicists aren't just looking for magic. They have suspects, theoretical particles that could cause this push. Forces are carried by bosons. Gravity has gravitons. Light has photons. The leading suspect for the fifth force is a ghost called the Z-prime boson. It's like a heavier version of light, but it doesn't interact with normal matter. It passes right through you. But it does talk to muons. It gives them that extra little shove in the magnetic ring. If Z-prime exists, it isn't alone. It needs a whole new family of particles to exist. Suspect number 2, the leptoquark. A hybrid monster. The standard model says quarks and leptons cannot mix. Leptoquarks break that rule. They could bridge the gap between the forces, unifying them into one master theory. This is why the wobble matters. It's a breadcrumb trail to a hidden sector of reality. We aren't just adding a page to the textbook. We are finding a whole new volume. But to prove any of this, we need more than a wobble. We need to catch the ghost. This is where the Large Hadron Collider in Geneva comes in. The particle smasher. Fermilab listens to the particles whispering. The LHC smashes them to see what breaks. If Z-primes or leptoquarks exist, the LHC should be able to create them directly. They are sifting through petabytes of collision data right now, looking for the signature. It's the ultimate needle in a haystack. But now they know exactly what needle to look for. The race is on. The first team to detect the fifth force carrier wins a Nobel Prize. But the implications go way beyond awards. It connects to the biggest mystery of all, because this fifth force might not just be nudging muons. It might be holding the galaxy together. Welcome to the dark sector. The 95% of the universe we cannot see. We know dark matter exists because of gravity. It spins galaxies faster than they should go. But dark matter passes right through us. It doesn't touch electromagnetism or the strong force. So how does it interact with anything? The fifth force. This new force could be the portal, connecting our visible world to the hidden dark world. The muon wobble is the faint knock on that door. A signal from the other side. If this is true, it means there isn't just dark matter. There could be dark atoms, dark chemistry, perhaps even dark stars and dark planets, occupying the same space as ours, totally invisible. A shadow universe right on top of us. And we just found the first evidence of it. This is why the standard model had to break. It was only describing the tip of the iceberg. We thought we were near the end of physics. We just realized we're barely at the beginning. The Fermilab result isn't an ending. It's a starting pistol for a new era of science. Bigger machines are already being planned. Machines that will kick that door wide open. We are about to explore a part of reality that no human has ever seen. But whenever humanity unlocks a new level of power, there is always a shadow side. Manipulating the fundamental code of reality isn't a game. It carries an existential risk. Some theorists worry about vacuum decay, the idea that our universe is in a false stability. If we push too hard, if we puncture the vacuum, we could trigger a collapse, a bubble of true vacuum, expanding at the speed of light, deleting physics as it goes. The muon results hint that the vacuum might be more fragile than we thought. Then there is the cost. These machines cost billions. Money that could fight climate change or hunger. Critics ask why chase a ghost particle when the real world is burning. It is a valid question. Science for the sake of science is a luxury. But history tells a different story. Curiosity is never wasted. When we discovered the electron, it was a useless toy. Now it powers the internet. When Einstein wrote relativity, it was abstract math. Now, without it, GPS would fail. The fifth force might seem useless today, but in 100 years, it could offer energy sources we can't imagine, or propulsion to reach the stars. The risk of ignorance is always greater than the risk of knowledge. We have to keep looking, even if what we find scares us. Back at Fermilab, the celebration isn't about utility, it's about truth. Dr. Aris and his team spent 20 years chasing a wobble. They missed birthdays, they worked through holidays. For a number. Why? Because we are the universe trying to understand itself. We are stardust that woke up, stood up, and built a machine to see where we came from. The Standard Model was our childhood security blanket. It kept us safe. But the muon is telling us it's time to grow up. It tells us the universe is stranger, richer, and more complex than we dared to dream. This discovery doesn't just rewrite physics. It rewrites our place in the cosmos. We aren't just observers. We are explorers on the edge of a new frontier. The anxiety of the crisis has been replaced by the thrill of the hunt. The fifth force is no longer a mistake. It is an invitation. So, where do we go from here? The blueprints are already drawn. A collider 3 times bigger than the LHC, a machine to manufacture the fifth force. If we build it, we might finally unite the forces. The theory of everything. A single equation that fits on a T-shirt, explaining the Big Bang and the butterfly. It will take decades. It will cost billions. But the journey has begun. The muon G2 experiment was the spark. The fire is just catching. We used to look at the stars and wonder. Now, we look at the subatomic and know. There is a ghost in the machine, and we are going to catch it. Physics isn't broken. It's just breaking out of its shell. The universe is waiting. Are you ready? This was a deep dive into the Fermilab anomaly. But there is another mystery. If the fifth force explains dark matter, what explains dark energy? That force is tearing the universe apart right now, and we have no idea why. We're covering the crisis in cosmology in our next documentary. If you enjoy videos that go deeper than headlines and actually explain how the world works, you're in the right place. Subscribe to the channel so you don't miss the next breakdown. Hit like if this video helped you see something differently. And if you have a question or a topic you want explored next, drop it in the comments. Your curiosity drives this channel.